Working on trying to figure out how to get to IO-Link indexes and sub-indexes this morning, which, you can get a lot of cool info on. And yeah, I want to do some videos showing, some of the things we can feature on it. But yeah, there's definitely a small hump that I need to figure out how to get over, and really be. Yeah, I just thought about it. I ought to host a sensor and IO-Link training class. Yeah, if I could get one of the manufacturers to do a IO-Link training, would y'all be interested? This is in-person training in Roanoke, Virginia. Let me know. All right, that doesn't help us any today, though. So I'm looking at this Pulse power supply, which, yeah, is a really cool power supply. We'll probably do a video featuring it. And if we go up, here's the process data. And the process data is really where we mostly stay at. And we can get the current, the voltage, and a few basic flags as to what's going on with the power supply. Now, if we go into the parameter values, and this is ISDU parameters, you can get all types of cool stuff. And really, here's where we need to get to. Like, never mind that we had an under voltage condition. How many under voltage conditions did we have? Or how many times did we drop below our minimum set point? I mean, this tells us, did we have a singular issue or are we having an erratic issue? Now, the one I'm actually looking at right now is number 67. That's the one I want to figure out how to do. This remote shutdown. Already, I feel like I need to explain why the world I would want to remotely shut down the power supply on a PLC. And typically, I would say I can't think of a single application that you would, but this arguably is one of the most important lessons for those that are starting out in the field. And I use it to show how your typical meter, and not just cheap meter, I mean, this is a 1587 FC, how if you don't have it on the right setting, how you can end up in a dangerous situation. Actually, mostly I use it to pitch the T61000 for people that are getting into the trade. I don't get a commission on that, but God, who knows how many of these I've actually sold. But I'm going to use Subindex 67 to simulate this power supply failing, which has turned out to be way more complicated than I wanted it to be. And so we'll use our imagination here right now. We'll act like we're having an issue with it. I want to check the DC voltage, and I go to, I tip the meter over. Do it again. I got the leads in here. Don't even have the Cat 3 ratings or the protective thingies on them. Just should, if you're, especially, here's a good example. Y'all just saw it on a video. You should have these twisted up like that, so, unless you actually need to untwist them. I don't need them like that right now. But yeah, so I'm gonna now, after I've fumbled around with everything, I'm gonna test this. And yeah, we have 24 volt. Now, whoops, I get down there. Now we're gonna use our imagination though. We're gonna act like we didn't have 24 volt. Well, the next thing you would check up here, and I will say nearly always people, and I'll say even experienced people, gosh, I'm gonna hurt myself sitting here trying to do this. They don't think to change their leads. So now we had no power at the top of our power supply. We have no power here, and we feel it somewhere else, but mainly now we feel there's no power on these wires here. But if I reach down here, and y'all get busy a second, because apparently I can't hold everything, and I switch it to AC, we realize, we do have power there. So that's the purpose of this lesson. And usually I use it, just to make sure they realize that they need to be really cautious, but also this is an advantage of the T61000 is it doesn't have an AC or DC setting right now. It says AC, but I touch it to my DC up here, and it switches to DC. Now we want to come down here, we want to test our AC, and it automatically switches. Now, on our previous trainer, this was super easy. The power supply we had a remote shutdown input, but we added the IO-Link, and it doesn't have a remote shutdown input. It has that index and subindex. So I need to figure out how to do that. So now that's interesting. True is 255, false is 0. But I should be able to do it by the web interface and hopefully work this out. So first thing I gotta do is I gotta manage to read the value. So this is the Turk Fin 20 manual, and here's the read ISDU. Gosh, I hate acronyms. Does anybody even know what that stands for? But anyway, kind of recognize this. We got a class of 67, an instance of 1. Attribute is the IO-Link port number. Got it. Attribute. Service code is 4B. So I kind of roughed out something here. I don't even know what I need yet. And here's kind of, that's why I figured I'd just go ahead and record this. I looked, and it looks like the first 3 of this controller are important. Well, they're all important, but looking over here, it looks like data bit 0 is going to be the index. Data bit 1, well, okay, least significant bit, most significant bit. So, okay, our indexes could get bigger than 32,000, I guess, or 64, 5, oh gosh, it's an unsigned integer. Luckily, I think, 67, I'll only use data bit 0. And then we have a subindex. I don't think this uses the subindex. So mainly, looks like though byte 0, 1, and 2 are important. So what I did is I created tags for ISDU. Back to that, let's see. Close all that back up. Oops, yeah. What I did is I created values for control ISDU and data ISDU, and I've just thrown them in as integers with a size 20. I have no idea what I need. And so following that, I dumped those 3 in here because I know we're gonna have to mess with those. Oops, copy and paste error. I don't know why I dumped that one in there. I got a little carried away. So yeah, go ahead and take that one out. And then I think, actually, now that I understand, now that I actually read the words, the attribute's not as important as I think the service code, because looking over here, we need a 4B for our service code for read ISDU. There's probably a write ISDU somewhere right around in here. We need a 4C, so I need to change the service code. I don't know that I can actually, I think I have to have 2 different ones. I don't think you can get to this service code. Let's go find out. So we should have service code up here. So let's double click on our attribute. I don't think service code's available. Seems like, and I don't know why it's not available, but yeah, once we throw a value in there, we'll go see if we can find it. But okay, so in the end, I don't think I need that one anyway. So we're gonna make it just like that. We'll go ahead and finalize this thing. Oops. There we go. And then I should be able to, let's see, throw some data in here, which I kind of roughed out. So it said 4B, 67, 1, and 1. And I got those plugged in. Then over here on the communications, I have 2, which tells it to go out the Ethernet port. That'd be a good video. One of these days I should do a video explaining this path. 1 tells it to go on the backplane, 2 tells it to go out the Ethernet port, and my IO-Link module is 192.168.20.98. So if I'm understanding this right, then if we kick back over here, well, really, I think anything should be valid. Well, actually 64 is the first valid one. Doesn't look like, oops, wrong one. Swirling all over the place now. Just like y'all do. Oh, then got lost because I scrolled. Oh, that's right. Yeah, I'm not sure what's going to happen here. Let's just try it. So I should be able to hit this test button, and I should at least get a happy done bit over here. So we'll toggle that. Oh, and it's definitely not happy. So I'm gonna hit my little dialog box. Parameter error in module configuration. Error 9. Okay, so I'm going to guess that I do have to throw something in this, so I think this should be 67. Oh, is that hex? I don't know what that is even. I'm going to throw 67 there. And then we'll toggle this off and back on, and now we'll get a happy bit. We did not get a done bit. Error in module configuration. Well, that kind of acts like it's, that is not an error. I think, well, here's why we have a help file, but it seems like from here the help file doesn't work. Let's see, because yeah, I need to get to the, and I really struggle with this whole new help system. I need a SIP error code. SIP error. Whoops, I have no idea what I just typed, folks. CIP space error codes. There we go. SIP error codes and number 9. Well, wait, number 9's invalid attribute though. That acts like no, if I had a wrong IP. Oh, you know what? Yeah, you remember I told you we needed that video on paths? Well, I've got these set up as separate IPs. That's port 2. This is port 4. So yeah, if we throw a 4 there, and now we turn this off, we turn it back on, and we get a happy value. All right, so now, okay, and I got the 67, and I believe, doesn't really say whether that, well, here you go. Is it in hex? Is it in decimal? What number comes after 69? 70, so it's decimal. There we go, that's solved. Okay, so now the question is, so that's the control. We want to go for the other one. Did we actually get anything into our data? And we did. All right, so I don't understand what any of this means yet, but what we're going to do is we're going to go to our nice little Windows snipping tool, and then I will make a new snip just so I don't have to write all this down. We're going to drag this over here. And then I should be able to go to our pin 20. We're on port 1. This is the pole's power supply. And we're going to check that remote shutdown, and we're going to hit the right. And then we're going to get a swirly timeout because I really have overcomplicated this just to make it feel like the power supply is totally dead. So I got to go over here now, and I got to turn a little auxiliary bit back on just to power that little fin 20 up. And then, well, first of all, did the power supply actually come back on? Well, impatient me is going to hit the reset button. Or the refresh button, and we're going to reload anyway. Okay, yeah, I mean, apparently you can't kill the power supply in the middle of doing one of these things, but let's see what it actually has in it now. So parameter. Okay, so we do have a remote shutdown now. So I should be able to go over here and do it again now. So we'll toggle the bit. Then we can go back over here, and then we drag our clipboard over. And okay, the only thing that changed is 5120 went to 5375. So my wild guess is 5375 is our sad value. That's going to turn off our power supply. And 5120 is our happy value. That'll turn our power supply back on. So now, actually it's already in there. Still not sure if I should probably have a separate one for this, but while we're learning, first of all, we're going to turn, actually no, I should try turning the power supply back on right here. So that said 4C was a right ISDU. Bytes. I should only need one byte, I think. But there are three. Oh. Yeah, here's the tough parts, but I think, okay, so I think I need a separate one. I'm gonna hit that pause button. I'm gonna copy and paste all this. So no, I'm not. I got 6700, and I was thinking wrong. This is a custom message, which means the source and destination don't work like if it was a read or a write message or one of those. I should change this to 4C and hit the OK button. And then according to my little copy and paste, I need to be at 5120. So I should be able to go over here, put a 5120 in right here. And right now we are shut down. I should be able to go over main routine and hit that. Oh, and we get a sad error again. Why did we get a sad error? Embedded service resulted in error. Well, and that's because we actually need to read the instructions, folks. And when we get to the 4C, we still do have data bit 0, 1, 2, but we continue on with 3 for what we're writing, which means that, yeah, in this case, the ISDU data doesn't matter. Now, the next question still is, can I swap this? But I'm just going to reuse this. We have it at 4C. That also means our length would need to be 4, because we need 0, 1, 2 for our index and subindex, and then the actual value will be in 4. And then we right click this. Oh, well, look at there. I did need that third one that I was thinking about. I did accidentally do that, but we're going to go ahead and start a rung edit here. Control CV, and we're going to bring that 3 back in. And then that happy value, what was the happy value again? The happy value was, yes, 5120. So I should be able to go over here and just enter 5120. My power supply is still shut down. I go over here, I turn off my test message, and I turn it back on. Woo! I even heard a little click over there. That power supply is on. Oh, read. Gotta hit the read button. There we go. So now the question is, can I change that service code, or do I need a separate message? So I should have a tag in here that says 4C in it for a value right now. So we're gonna monitor it. Open up our message, and we are looking for, well, there's a 4, that's the length though. 4C, well, one, what is 4? Well, they probably switched over. These are hex, so it would be here. There is not, so I don't know why that's hidden. That would be an interesting thing to learn one day, but so I will need a separate message to do this. We're actually only halfway through this because I need to do this in a micro 820 because that's what's actually switching this fin. I'm just more familiar with messaging in Studio 5000, so it's easier to do it in it. So now I got to figure out how can we do this in a micro 820. So let me rough some stuff out. Well, I might as well record doing this part too, because just in case it works, I'll probably have to review back to this if I decide to make a video on it. So all I've done is drag a new rung down. And we're going to drag that down. We're going to double click on it. And up here on my filter, I'm going to type MSG. And then we're going to widen that out. And we want a SIP generic message. Now I'm just going to fill out tags for all of these. Okay, so all I did was rough some out, and so now we want to work through some of these. So our first one is the control config, and then in this case, I want to leave that actually, so these are zeros if you have nothing in it. Mainly I was looking at this trigger type. If I leave that at 0, it only trigger when I fire it, and for now, that's going to be perfectly fine. So I'm going to put something in here. And then we'll go ahead and make a tag. Then we have our app config. All right, this one's definitely going to have some important things in it because this has our service class instance and attribute. And so I'm going to try to plug them in over here. So I should be able to go over to Studio now. I should be able to hit this ones. So service is 4C. Now that's in hex. And connected components, the service code is an unsigned integer. So we need to know what 4C is. So we're going to go to our fancy Windows calculator. And on it, we're going to hit the little dash, 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 and we're going to select programmer. And then I want a hex value of 4C. That tells me we need a decimal of 76. Now be really careful. Don't hit the enter key when you're doing it this way. I'll go ahead and do it just so we can see how I always screw up. If you hit enter on that, then that does put it in. But if we hit it again, it actually makes this wrong. I wish they would do something about that. We're going to hit our undo button. That gets us back to what it was. And we'll go back in here. Okay, so then we need a class, and so for our class, we are at 67, which is also a hex value. So we'll need to go to our calculator, and we'll backspace that out and put a 67 in, and decimal, that's 103. So we're going to put 103 there. And then we have our instance and attribute, which were both at 1. And 1 in hex and 1 in decimal are the same thing. So we should be able to put a 1 there. Should be able to put a 1 there. Don't believe these two will matter. And then as strange as it seems, we're going to hit the cancel button. Because when we hit the enter on these, that did put them in. And that'll keep us from screwing that up. All right, so we have a target. And on the FIN 20... on the Micro 850, just to keep us really good and confused, I should do a video like universal paths, but 4 is the Ethernet port on a Micro 850, and then 192.168.20.98. So we're good there, and the rest of those shouldn't matter. Then we have the R requested data. All right, this is where I need to put... To start with, if we're going to do a read, I need to put 67. I am going to make these line up. Just so they line up with Studio. Then the default number on an array and connected components is 1. Yeah, we're going to change that to that. Just so that all the data lines up. That way I don't lose my sanity trying to kick this over. All right, so requested data. And to start with, I should just need 0. I should put 67 right there. That should give me that 5120 number. Do I need a length? No, the length will come from the FIN 20. Oh, darn it, I did it again. You can't hit the OK button when you're doing it that way. That's right, I should get a result data and a result length. I think Oh, let's go for it. So we're going to go ahead and download that. All right, so now when I toggle this, well, actually, I always get confused on this. We want this to stay false. That's our goal, and we want to see a value right here, I think. So we'll go ahead and toggle this bit. Well, we stayed. Oh, nope, there it goes. All right, so that did not work. So now we got to go figure out why. So we're going to open up the status. We're going to go have a look here. We definitely have an error, 55 and 115. So 55 and 115. We'll highlight this instruction and hit the old F1 key. And we need to go find our status data type, status error codes. We have an error of 55, 115. Message timed out for while waiting on a response on the link layer. Whoa. Yeah, I don't even know what that means, folks, but let's go double check our message stuff. Let's just hope we got a really simple typo. Oh yeah, well, eventually there will be a great video showing how to elegantly do indexes and sub-indexes. Apparently I'm going to grind at this for a while. Of course, I'll be back and forth on it because I do have it successfully done in Studio. So I know it can be done. So now I just got to figure out, it's got to be something in those values. Or my path. Maybe I'm wrong on that path. Of course, we hit the old Googler looking for information, and there's nothing more irritating than your videos coming up when you search for something you don't know how to do. Of course, half the time it is because I forgot how to do it, but I'm wondering, apparently I have done a subgeneric at some point, but let's go in here and see what Rockwell support says. Okay, so I started kind of backing through things. I mean, I did the hexadecimal to def on my class and instance and attribute and all that fun stuff, and I've checked my target that many times. I finally took that REQ data and I threw a 0 back in it. And when I did that, I got a happy. If you didn't know it, happy is false. And now we have an RES length of 16, which means we have things in here, hopefully. And we do have things in here. Now, ultimately, we're looking for a 5120, and we are nowhere close to a 5120. So no doubt this is going to whip me today because, yeah, I'm getting super inconsistent results from download to download. So as I'm fiddling with something, I'm probably writing something into some crazy buffer. I don't know. Anybody out there really good at generic messages? Because, yeah, I've downloaded a couple times playing with this. And, I mean, we've been here a couple times in this video. Really, this thing should throw a little result in, and I go and I start messing with these. Eventually it starts spitting something out, but it doesn't make sense what it's spitting out. But that gives me enough. We could do a video on understanding the index and sub-index of IO-Link in Studio, and I think there's some really cool data that we need to be getting for diagnostics. There's a ton of diagnostics data on a lot of your IO-Link devices. Anyway, anybody help me out with that connected components workbench? That'd be great.